Happy Tuesday, guys. We are working our way through chapters 10 still. We have, I think, 3 more sections. Just kidding, more than that. About 4 more sections to get through before we are finished with chapter 10, but we are moving right along. So, section 7 is talking about similar figures. So first of all, we are going to talk about what that is, and then I'm going to show you a couple examples that you guys will see specifically on the homework that you have. Your homework tonight is, I think, 10 questions, so not a lot tonight, mainly just asking if they are similar or to find the missing sides. So kind of the same thing that we've been doing as far as finding the missing sides, but this is a little bit different. It's using proportions, which we have talked about before. So if you don't understand, please make sure you watch this all the way through, or at least get to the example that looks like the one that you're stuck on, so it helps you. So looking at what a similar figure actually is. A similar figure are figures that have the same shape, but not necessarily the same size. So if you look at this, and I know there's a lot on this screen, but there are 2 triangles. They are similar. If you look at them, they look the same. That is not the way to tell if they are similar. One is smaller than the other. So I'm going to explain on this slide why they're similar, what's matching. So just really quick, one thing to kind of remember is when you are naming a triangle, it's just the 4 sides. So RST is this triangle, XYZ is this triangle. If you want to do STRYZX, that's fine too. Just as long as you have all of the points named, that's naming a triangle. So this right here, the little squiggly line between them, that represents that they are similar to one another. You cannot automatically do that without actually looking at them. So what that means is, if you look at the angles of R and X, they are both 118, S and Y are both 26, and then 36 and 36 are T and Z. So they all have matching angles. So angle S and angle Y are equal and so forth. So those are what are called corresponding angles, meaning they're essentially the same. That's just the terminology for it when you get into geometry. So we've talked about classifying shapes based on their angle and their side. So with triangles, you guys were naming them with side and angle. So with angles, you could name them acute, right, or obtuse. And then with their sides, you could name them scalene, isosceles, or equilateral. So you should have had 2 names per triangle because you're determining both. And then looking at their sides, okay, this is where it's kind of the tricky part. So I know S and T is 6, and then Y to Z is 3. So they're not necessarily equal, but if you actually look at the triangle, 6 divided by 2 gives me 3. 4 divided by 2 gives me 2. And then 3 divided by 2 is going to give me 1.5. So all this triangle is this first triangle divided in half. Okay, so I have matching sides as well. So S to T is similar to Y to Z, and then Y to X is equal to S to R, and so forth. Okay, so then I'm going to move into some examples with that. So clear this. So this is an example that you guys will see as far as identifying similar figures. So the question is, which trapezoid below is similar to trapezoid DEFG? So this right here is this right here is the trapezoid that I'm using, and I'm picking from, I'm just gonna label them 1, 2, and 3 to be able to reference to them a little bit quicker. So if you look right here, I have 12 and 4. So think about the relationship between those two things before you look at anything else. So on the sides, I'm multiplying by 3. So when I do that, I'm also going to look at the other side. So if I look at 6 and 14, multiplying 6 times 3 does not give me 14. The relationship between those is I'm really subtracting by 8. There's not really a relationship between 6 and 14. I can't multiply 6 by anything to get 14. On trapezoid 2, I have 3 and 9. Right here, I multiplied by 3, which was similar to this trapezoid up here. And then lastly, I'm also going to look at this. So 5 and 10. Right here, I multiplied by 2. That's not what I multiplied in my example, or kind of my trapezoid that I'm trying to figure out what it's similar to. So the trapezoid below that is similar to trapezoid DEFG would be trapezoid 2, or on your homework, it would be W, X, Z, Y, or however you want to say that, is similar to DEFG. Okay, so that's all you're doing when you are identifying. So you're looking kind of for the relationship between the two of them, figuring out what you multiplied by, what you added by. The other way to do this, because some of them will not be that easy, unfortunately, is to set them up as ratios or proportions to one another. So if I am doing this triangle, so the D, E, F, and G, the other way to look at this is to kind of take E and F. So I have 4, and then I could take my sides of these triangles, so right here, and I'm going to set them and simplify them. So what that means is if I'm taking 4 over 6, and then 4 over 3, and then 4 over 5, and finding the relationship between the E and F, and then Q and R, E and F, and then X and Y, and then E and R, or sorry, E and F, and then K and L. So then I can take and do G to F or F to G, so the 12, and then make it equal to these bottom pieces. So I have then 12 over 14, which would simplify. I have 12 over 9, and then I have 12 over 10. So what I'm looking for between these two numbers is if they're equal to one another. So I can simplify 4 to 6 to 2/3. I can simplify 12 over 14 to 6/7. I can't simplify anymore. 12/9 I can simplify to 4/3, which if you look, they're similar to one another. And then I can simplify 12 over 10 to 6/5, which these are not equal to one another, and these are not equal, but these are equal. So setting up your sides equal to one another is a way to do that, which we will look at an example like that in a minute. So looking at this side, we are going to set up a proportion. That's how you would go about solving this problem. So I'm finding the side measures of similar triangles. So I have triangle TRS, and it has side lengths of 5, 6, and 4. And then I have ZXY, and then it has 15 and 18, and it is missing a side. So what I'm going to do is I'm going to take two sides that they have in common. So you can either use 6 and 18 or 5 and 15. I'm going to use, let's use 6 and 18. So I'm setting them as a proportion. So what that means is I'm setting these two sides on as a fraction, so 6 to 18. So because they are different triangles, they're going to go on different sides. And then if I'm setting it equal, so what is on top needs to be from the same shape, and then what's on bottom needs to be from the same shape. So because my 6 is on top, I'm going to use the 4, and then my bottom is what I'm trying to find. So whatever letter you want to use, I'm just going to use X right here. So now I have 6 over 18 is equal to 4x, and then I'm going to solve this. So when you are solving a proportion, you are cross multiplying. So I have 6x, or 6 times x, which equals 6x, and then I have 18 times 4, so I don't know that off the top of my head, so I'm going to multiply. So 8 times 4 is 32, and then I have 4 times 1 is 4, plus 3 is going to give me 7, so I have 6x is equal to 72, and then I'm going to divide both sides by 6 to get x by itself. So remember, a letter and a number next to each other means multiplication, so I would do the opposite operation to get x by itself. So now I have x is equal to 72 divided by 6, so x is equal to 12. I could have also done 5 over 15 just to show you how this works, and then done 4x. So I would have had 5x. I'm going to erase this part right here. Right. So I have 5x, so 5 times x, and then 15 times 4 is equal to 15 times 2 is 30. So if I multiply that times 2 again, or add it to itself, I would get 60. And then if I divide 5, both sides, I would get x is equal to 12 as well. So either way, you're going to get your missing side as 12. Then looking at this last example, there is one example like this in your book. I'm not sure if you have an example like this. You have one example like this in your homework. So if you don't understand it as you're going through your homework, just look at this example. So these are called indirect measurements. So it's when you use similar figures to find the length, width, and height of objects that are too difficult to measure directly. And I didn't type out the entire example in here, but the example in your book talks about a Old Faithful at Yellowstone National Park that shoots water 60 feet in the air. So that would be this triangle. And then this other triangle is representing the shadow of a 63 foot shadow wide from a tree that you don't know the height of. So what I'm going to do in this example is also set up a proportion like I just did with finding the triangle. So I'm going to use the same, these are going to be on the bottom together, and then these are going to be on the top together. So I have x over 63 is equal to 60 over 42. So again, make sure that the same two sides are lined up on the top and the same two sides are lined up on the bottom. This is from one shape and this is from one shape. So I'm going to multiply. So I have 42x, and then I have 60 times 63. So I'm going to multiply that to the side. 0 times 3 is 0. 0 times 6 is 0. Then I'm going to add a 0. 6 times 3 is 18. 6 times 6 is 36. Plus 1 is 37. So I have, this is equal to 37, or 3,780. And then I'm going to divide by 42. And just so I don't take up more of the screen, if you divide that, if you want to use a calculator, that's fine. 3,780 divided by 42 is going to give you 90. So your missing side is 90 feet. So if you are trying to find the missing side length, you're going to set up a proportion and find it that way. And then if you are finding a similar figure, you can also set up a proportion or kind of just figure out what you multiplied one side by if that's the case. If it's something that's different, so like if one side was 5 and one side was 14, you can't multiply 5 by anything to get 14 that you know of. So I would set it up as a proportion to then find what it is equal to. So if you guys have questions, please make sure that you are reaching out before you do your homework, just so you have an understanding. I'd rather you ask questions in your homework be late than you turn in homework that you had no idea what you were doing. So please ask. Please let me know if you guys need help, and I hope you have a great day.